This video is a brief introduction to distortion and clipping. It corresponds to section 18.2.3 of the Applied Analog Electronics textbook. Now, when we're talking about amplifiers in this course, we are usually talking about linear amplifiers. Amplifiers in which the output voltage is a straight line when you plot it against the input voltage. Now, technically, these should probably be called affine amplifiers rather than linear amplifiers because they're not guaranteed to produce a 0-volt output with a 0-volt input. We generally have some DC biases to deal with. But they're called linear amplifiers because the affine function is something that electrical engineers didn't remember the name for, perhaps. So, straight lines. All right, let's take a look at what we might see, though, if we're looking at a real amplifier. And here I'm showing a linear amplifier with a nice blue line here for what it should be doing. And here it's really a linear amplifier because the 0 input produces a 0 output, and the whole thing's a straight line. The slope of the line, incidentally, is the gain. But when we're dealing with real amplifiers, we very rarely can get arbitrarily large outputs. And if you've got a large gain, here we've got a gain that takes 50 millivolts to 2 volts. So that would be a gain of 40. Well, if we had a 1 volt input, we'd have to produce a 40 volt output, and we don't necessarily have that available from our power supply. So what tends to happen when we work with amplifiers like this, that at some point they stop being linear. And one of the most common things for them to do is to clip. That is to say, as soon as you get to the largest voltage or the smallest voltage that you can output from the amplifier, it just stops there. It doesn't go any further. And that's the red line you see here. In the middle part, where the input voltage is still within a legal range, so the output voltage can sit between the plus or minus 2 volts that this particular hypothetical amplifier can do, the function looks exactly the same as a linear amplifier. So it behaves like a linear amplifier up to a point. And beyond that, the output's constant. That is clipping. Now, clipping causes some distortion in your waveforms. That is to say, the shape of the waveform is different on output than on input, even if you have a very simple input, like a sine wave. And so let's take a look at what happens to a sine wave if we put it through this amplifier that clips at plus or minus 2 volts. So the red sine wave is what we would get if we had something going through an amplifier that was just a linear amplifier and putting out something that's 6 volts peak to peak. So plus or minus 3 volts as the limits. If we clip it at 2 volts, it doesn't go that any farther. The peaks, both the positive and the negative direction, are cut off. And the resulting waveform no longer looks like a sine wave. If we look at it in terms of its Fourier transform, which is beyond the scope of this course, but it expresses the energy of a periodic waveform in terms of different frequencies, you'll see that not only do we have the sine wave, the fundamental frequency, but many of its harmonics will also be present. And so we've taken something that was a pure sine wave and turned it into a complex waveform that has many different harmonics. This is distortion, and it's often measured in terms of how much you get in the way of harmonics. So a good linear amplifier produces almost no harmonics. So the total harmonic distortion is often a measure of quality for an audio amplifier, for instance, because you want the total harmonic distortion to be very small when you're trying to produce a correct reproduction of what the input is. Now, there are amplifiers that are designed to do distortion. Some guitar amplifiers, the old tube amplifiers and ones that try to imitate them, deliberately distort the waveform in a way that's different from clipping. They produce a softer transform function, one that doesn't have a sharp corner going from linear to nonlinear or to constant, but they have a sort of a rounded, slowly reaching a limit. And that sort of distortion changes the sound quite a bit, and people who play electric guitars often like the effect of the distortion that they get from those old amplifiers. But for the sorts of work that we do in instrumentation and scientific work, it's very rare that we want to have distortion going on. So usually we're going to want to design all our amplifiers to stay within the clipping limits of our amplifiers. We'll have ones that have pretty sharp, it works up to here and then it stops. And we want to stay within the region where it continues to work. This is a very simplified view of clipping and distortion. If you want to have a more complicated view, you really need to start looking into things like the Fourier transforms, and that's beyond the scope of this class. For us, it's enough to just say, keep your gain small enough that your input signals will not be clipped on the output. And that mainly means that you need to know what the output range of your amplifier is. And there are kind of two types of amplifiers that we end up dealing with. One is called rail-to-rail amplifiers, where it gets very close to the negative power rail, very close to the positive power rail, whatever those are. For us, that's often 0 and 3.3 volts, or 0 and 5 volts, but it can be whatever the power rails are for that amplifier. And a rail-to-rail amplifier gets very close to that, within a few millivolts of the rails. And that can be very useful because basically your output range is as unlimited as it can be with the power supplies you have available. Another type of amplifier has much more limited range, and then you have to reduce the gain quite a bit more in order to stay within the legal output range of the amplifier. And it has to do with the internals of the amplifier and how it's designed, and there are trade-offs, different characteristics of the amplifier. It's hard to get everything you want all at once. And so you need to be paying attention when you order an amplifier, whether it's rail-to-rail or has a different output range. And then you have to pay attention to what the output range is and make sure that the gain you set isn't so high that the input you have would cause clipping. And that's basically all we need to know in this course about distortion and clipping.